Hello student, welcome to the course of power generation system. In our last lecture we have studied about the solar system, the solar energy production. We studied about the introduction, that how from the solar energy is converted into electricity. Today we were going to study about the solar panels and the solar charge controller and inverters. So solar panel, we know that the electricity produced with the help of solar cells. So solar cells are made from semiconductor materials that convert the light, the sunlight, or we can say the photon, into electricity. And the most common material used as a semiconductor during the solar cell manufacturing process is silicon. Then we have different types of solar panels. So one of them is monocrystalline and the second one is polycrystalline. Both these type of solar panel have cells made of silicon wafers. Then the wafer are assembled into rows and columns to form a rectangle that is covered with a glass sheet and framed together. So in this way, in the solar panel we have many solar cells made of silicon wafers. Mono and polycrystalline panel vary in the composition of the silicon itself. In monocrystalline, solar cells are cut from a single pure crystal of silicon, whereas in polycrystalline, solar cells are composed of fragments of silicon crystal that are melted together in a mold before being cut into wafer. So this is the basic difference between the two, and the third one of the solar panel is called a thin film panel and are made from a variety of material, but mostly from cadmium telluride. So these are the different types of solar panel: monocrystalline, polycrystalline, and thin film. Monocrystalline is the oldest one, and the latter one, poly and thin film, are developed later. Here is some comparison between the three. That is, monocrystalline have efficiency of about 20% or somehow 23 to 25%, whereas polycrystalline efficiency reaches 15 to 17, and thin film have 11% of efficiency. Monocrystalline are expensive among the solar panels. The polycrystalline is never developed, and thin film is the cheapest type of the panels. And we know that monocrystalline is purely made from silicon, and polycrystalline is a fragment of silicon crystal melted together, and thin film can save on installation due to weight differences, and it is not highly weighted. Monocrystalline appear black in color, and poly is appear blue in color, and extremely new developed thin film solar panels. Then, as we know that a solar panel is made of solar cells, so a single solar cell of 4 centimeters square develop a voltage of 0.5 to 1 volt, and it can produce a 0.7 volt power when exposed to the sunlight. Typically, the best designed solar panel have a maximum efficiency of 25%. So solar cell model or solar panel convert the solar energy into electricity. These are mounted in such a way that they collect maximum energy from the sun, and mostly solar panel are rated to a voltage 12 volt. The panel are connected in series, mean we have solar panel that we can connect it in series or in parallel, and in this way we form a solar array that produce a higher voltage, typically of 24 or 48 volt in a stand-alone system, or it can be several hundred of volts in a grid connected system. So solar panel have a voltage, specific voltage 12 volt, and we can connect it in series or parallel combination, so we can get our desired voltage. Suppose we have a 4 solar panel, and it is each one of them is 12 volt and 12 watt the power, and each have a current of 1 ampere. So when we connect these array in series, the output will be 48 volt and the power will be 48 volt, and the current is the same 1 ampere as we connect this in series, and we know that in series we have the same current and the voltage will be up. Next, when these solar panels are connected in parallel having the same rating, that is each have 12 volt and 12 watt is the power, and each have 1 ampere of current, in parallel combination the output will be 12 volt, the voltage remain the same, the current will be more, that is 4 ampere in this scenario, and the voltage will be 48 volt. So in this way we can combine different way in series or parallel, and we can get the desired voltage current. Then we have a solar charge controller. If the generated current overcharge the battery, if the battery is overcharged, in this circumstances the battery may be damaged or will be damaged. Moreover, if the battery is completely discharged, it will destroy the battery. So the solar controller prevent the battery to undergo these conditions. So means it is a sort of protection for the batteries. Then we have inverter. We know that electricity generated from solar panel is DC, whereas the most electrical appliances used in our home, especially or in shops, etc., or office, or AC. So we need to convert this DC into AC. For this purpose we use inverters. Also, the solar system is connected to the grid, so the generated DC voltage must be converted into AC. So for this, an inverter is used. Thank you. That's all for today.